Alright guys, we're machining some steel here. I figured I would go live. Everybody has always asked. Let me switch over here for a second. Alright, so I'm machining some steel. I've had a lot of people say, how does it do with steel? How does it do with steel? So this is the MR1 machining steel. This is mild steel. I have a 6-screw end mill. I'm going 5,000 RPM and 84 inches a minute. I could probably run it harder and faster, but I've never run a 6-screw end mill before. I wasn't really sure how hard I could push it. So this is the first go with a 6-screw end mill. I have machined steel, but this is the first 6-screw end mill. It's a carbide end mill. Let me flip you guys back around. I'm using the misting system. I know it's super loud, but it's a shop, and if you want to see it in real time, there's not much I can do. Trying to zoom out. There we go. Like all the way in or all the way out. Nothing in between. I'm 70,000 depth of cut, 30,000 step over. Oh, it looks like I dropped just for a second there. I was trying to view the chat, but I need to drop this lower. If you have any questions, just leave them in the chat. Let me see. How do I see the chat? Can one of you send me like a test message in the chat? I'm trying to see how to view it. That wasn't it. There's chat settings. Oops. Sorry guys, I dropped off there for a second. Okay, it just pops up at the bottom. Thanks for the chat there. I was trying to share this, and it looks like I froze the connection for a second. If you're curious, this part is for the CNC lathe that I'm building. Well, that air move's unfortunate. Yeah, I do mostly aluminum, but in this application, I was going to have to do all these parts on the manual mill, so I decided I have a CNC, why would I do them on the manual mill? Also, as loud as everything is in here, I don't know if you can hear me or not, so hopefully you can. The reason I punched a hole all the way through in the center, so when I flip this over, I can probe that hole. And that will allow me to make sure that all my features on the top are exactly relevant to the features on the box. These end mills I picked up from AliExpress. Carbide end mill. That's the information on the end mill. I'll grab one that's not in the machine. So the chips are slightly gold. It means I'm getting just a smidge of heat. So what I could do, I could turn the amount of mist up. So I turned the volume of mist up just a little bit. My chips were silver, now they're gold. That could be my end mill is also getting a little bit dull. I really would hate to have this end mill break right now because I don't know where to restart the machine. I'm going to turn the... I turned the mister up a little bit higher. Now it's going to get foggy in here. climb cutting, the conventional cuts generate more heat, and that could also be why some of those chips are gold and some of them are silver. The conventionally cut is going to generate more heat than the climb cutting. When it was just doing circles in the middle, it was doing all climb cutting, and now it's doing both directions. If it wasn't such a big part with such a long runtime, I wouldn't care if the end mill broke, and I would push it harder. But I really don't want this end mill to break because starting over would be really hard. Well, it would take forever. It would air cut for an eternity. I could just resume at whatever line I thought it was at, but that doesn't always work. Flood coolant on just a little bit. Just dribbling a little bit onto the part, keep it cold. Yes, that is a 6mm end mill. The reason I went with a small end mill is now I don't have to do any tool changes. I can do all my holes and all of this milling with one program. There are a lot of opportunities where I could run bigger end mills, but then I would have to do tool changes. Every tool change is a chance to make your part less accurate. If all of the features are run in a single program, those features are all relative to each other. Anytime you load a new program and you touch off a new tool, you introduce opportunities for errors and tolerance increases. anybody who's just joining, this is my Langmuir Systems MR1 cutting mild steel with a 6-flute end mill. RPMs are 5,000 RPMs. Step over is 0.03 inches. Step down is 0.07 inches. And I'm traveling at 84 inches a minute. I'm pretty sure I could go a lot more aggressive, but I don't want this tool to break because it's a really long running program, and I don't have to start it over. Strategy here. I'm just basically leaking a little bit of flood coolant onto the work surface. It's keeping the part cool, but I'm using the air blaster to evacuate the chips, so I'm not recutting chips. Chip recutting is the fastest way to kill an end mill. Well, it's not the fastest way, but it's a very has a very high contribution to the life of the end mill if you're recutting chips. Hey guys, if you're watching, go ahead and hit that thumbs up button if you can. That will really help. It'll basically tell YouTube that this is worth sending out to people. It really helps out the channel. Uh-oh, my screen went dim. Looks like my battery is dying, so I don't know how much longer this live stream is gonna last. I'm just gonna let the phone on, and when the battery dies, the stream will end. All right, I have 5% battery. I'm going to go ahead and shut down the stream so that I can actually save this stream. Thank you all for watching. Thanks for the thumbs up. I really appreciate it. That really helps the channel. And if you have any questions about the Langmuir Systems, cutting steel, or anything else, put those in the comments of this video. And I will see you all later. Oh, I will. Follow me on my other social medias like Instagram, Facebook, and I'll definitely be putting some pictures of this finished part. See you later, guys.